Hello, fabulous Algebra 2 people. So this video is revisiting law of sines, law of cosines, which you did in geometry. Hopefully you got to do that activity where we went out to the pool and measured various distances, angles with the iPads, and then used law of sines, law of cosines to figure out unknown lengths. So we are revisiting that. Law of cosines and law of sines are used to find the angle or side length in what we call an oblique triangle. All that means is it's not a right triangle. All right. If you're doing law of cosines, basically, this can get much deeper. For our purposes, what you're looking for is given information that is either side angle side. In other words, you have two sides and a given angle, which would look like that. Or you can do law of cosines with side, side, side and find an unknown angle if you were given all three sides. Those are the two cases we're going to focus on. In later math classes, you'll see how you can do even more cases. So if you are given side, 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 this is really important that you always find the largest angle in a triangle before you try and figure out anything else. So a little review. Remember that if you have a triangle, the largest angle is always going to be opposite the longest side. So if you're given side, 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 take whatever the longest side is, the angle opposite will be the largest angle. The other thing you have to make sure of before you start doing law of cosines is that you even have a triangle. So remember, if you have three sides, the sum of the measures of any two sides has to be strictly greater than, not even equal to. Otherwise, you don't have a triangle. So in other words, if I've got a side here, and here's the other two sides, these two, right here and here, they have to be, when you add them together, have to be greater than this third side. Otherwise, there's no connect. You don't have a triangle. So you always want to add those two smaller sides, make sure it's greater than the third side. And then last but not least, if you're doing law of sines or law of cosines and you get an error on your calculator, it might be in how you set up the problem, because remember, sine and cosine, cosine is adjacent over hypotenuse, sine is usually opposite over hypotenuse. Hypotenuse is the longest side in a triangle. That means that ratio is always going to be less than 1. So if you're trying to find an angle and your ratio is greater than 1, you're going to get an error on your calculator. Okay, so let's get into it. Up here we have the three different forms. Notice that the first, a squared equals b squared plus c squared, that's really Pythagorean theorem, because Pythagorean theorem is a subset, actually, of the law of cosines. If you were to take the cosine of a 90-degree angle, it would be 0. So that's why in a right triangle, you just need the first part of the law of cosines. But we're not doing right triangles, so we need the whole formula. So a couple things to notice, that the bookends here are always going to be, here is the angle, the capital letter, and here is the side opposite that angle. They are always on opposite ends of this. Everything right here represents the side. I'm going to erase this right now and go back to this. So right here, this part represents the side angle side. This then would be the opposite side to that particular angle. So it all depends again on what your reference is. If you're trying to find little a, then I would be using this first one. If I was finding little c, I would use the last one. So it all depends on which side you're finding. They're just variables. Okay, so it's more about the relationship. All right, so some suggestions. Number one, you're going to need a calculator. I suggest you, as we set them up, you then pause the video and try and work out the problem on your own, because a lot of this is just how do you enter it correctly on your calculator. Make sure your calculator is in degree mode, and you want to make sure you know where your parentheses are, because that makes it a lot easier to set up these problems. First thing I would always do is I draw a triangle. I don't really worry about the lengths of things, just draw a triangle. But I am noticing it says triangle ABC, so I will label my triangle little a, little b, little c. And let's see what it gave us. It gave us that little a is 15 and little c is 8. And we know that angle B is 127. And we want to find the length of side B. So we're not solving for the whole triangle like you will be asked to later on. When it says solve the triangle, that means find all the lengths, all the angle measures. We're just finding one particular item. So notice I was given side, angle, side, 8, 15, and 127, the angle between those two sides, and we're going to find B. So we are using the middle formula that says b squared equals a squared plus c squared minus 2 times a times c times the cosine of angle B. And then we're going to substitute in the given information. So we have 15 squared plus 8 squared. And again, this will all equal b squared. Just like when you're doing Pythagorean theorem, when you're done, you are going to have to take a square root. 2 times 15 times 8 cosine 127. All right, so all I did was plug in the given information. Now, the beauty of a calculator is you really can just enter this all in one sweep, starting from the beginning. So I would start here, and I would just enter it as I see it. If you go through and do that, so you're going to actually enter in 15. You have a squared button on your calculator. You should have something that looks like that. So you could just hit 15 and then hit that button, or you can do 15 times 15. That's up to you. So 15 squared plus 8 squared minus 2 times 15 times 8. You actually don't even need to put in a times before the cosine 127, but if you do, that's fine. It doesn't really matter. So take a second, try that, and then if you want to pause, I'm going to keep going though. You should get b squared equals 433.44. And remember, to get our answer, we have to take the square root of both sides. So we get b equals 20.82. All right, again, it's really important that you just try and go through and enter all that on your own. You can always pause the video, try it out, make sure you're entering everything correctly. If not, then send me an email, or we can meet individually to take a look at what you're doing. All right, this next example is one where we have side, side, side. So we have triangle XYZ. So here's X, here's Y, here's Z. That's going to be little x, little z, little y. And then writing down what we are given, X is going to be 3, and Y is 7. And let's see, Z is 9. All right, before we even start, because we were given side, 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 I want to make sure I even have a triangle. Since 7 plus 3, the two smaller sides, is strictly greater than 9, we're good to go. We have a triangle. So in this case, we're going to try and find the largest angle. So what that means is we're looking for angle Z. So setting up our law of cosines, here is your side angle side, even though that angle is unknown. So that means I'm setting it up this way. Z squared, little z squared, is going to equal x squared plus y squared minus 2 times x times y times the cosine of angle Z. That's what we're looking for. All right, so let's start to plug in what we know. We know Z squared, so that's going to be 9 squared equals 3 squared plus 7 squared minus 2 times 3 times 7 times the cosine of an unknown angle. That's your setup, and it's really important that you show me the setup. Don't just put things into your calculator, because finding the unknown angle is kind of tricky, and if you don't respect the order of operations, you're going to get a wrong answer. So what we're going to do is we're going to do this step by step. We're going to peel away everything because our goal is to isolate cosine Z. All right, so let's see how we do that. So we have here 81. I'm going to subtract the 3 squared, which is 9, and I'm going to subtract the 7 squared from both sides. So 81 minus 9 minus 49, and let's see what that gives us. So that took those away, so we have 81 minus 9 minus 49, and that gives me 23. My eyes are not very good today. I'm hoping that's right. So now we have that, so we have 23 equals negative 2 times 3 times 7, so that is 21 times 2, so that's negative 42 times cosine Z. All right, so we still need to isolate our cosine Z, so I'm going to divide both sides by negative 42, and so that gives me 23 divided by negative 42 gives you negative 0.548. I hope I'm reading these right. Realizing this is kind of hard to do when you can't really see. And that's our cosine Z. Well, that's great. Okay, so far we know everything is okay because our ratio, our fraction, our decimal is less than 1. It's between negative 1 and 1. So we know we've entered things right. If you have a number that's bigger than 1, it means something didn't work out right. Now, how do I solve for Z? I don't want cosine of Z. I actually want to know what is angle Z. So if you look on your calculator, behind your cosine button, you should have something that says inverse cosine. So I don't know if you remember from geometry, that's what that sole purpose of that button is, to solve for an unknown angle. So what you're going to enter on your calculator is inverse cosine, so you have to hit second and then your cosine button, and then negative 0.548. That is going to then allow you to find angle Z. So you're taking the inverse cosine basically of both sides, and it cancels this out. So when I do second cosine, negative 0.548, and you don't want to do too few decimals or you're going to get an answer that's not very accurate. However, your final answer you can round to the nearest degree. No one measures degrees in more accuracy than just a whole number. So you should get 123 degrees. All right, so again, try that from scratch. You should always try these out, because a lot of these is not so much, it's not hard to set up the problem, it's making sure you enter things correctly and solve them correctly in your calculator. All right, let's try this last example. Again, we have x, y, z, 3, 7, and 11. So it's another side, side, side. So we have 3, 7, 11, and notice if I add the two smaller, it is going to be less than my third side. So I have no triangle, which means there's nothing for me to do. So please make sure you even have a triangle if they give you side, side, side before you continue. All right, and now we're going to go on to law of sines. Okay, so here we have the law of sines. This law of sines is basically setting up a proportion. So the sine of an angle is to its opposite side as the sine of another angle is to its opposite side. And it doesn't matter which one you choose because the sine of this angle would be to its opposite side. So the main key is that in order to do the law of sines, you have to have a pairing. So you have to have a pairing of a side and its opposite angle for at least one pair, because we're going to be solving a proportion. So that gives us what you might say a scale factor, and then there should only be one piece of missing information. All right. And it doesn't matter now. Notice that in the proportion, so here are your various law of sines, and you only need a proportion. You don't necessarily have to do all three, but notice on the first set you have the sine of the angle is on top, and in the second set you have the sine of the angle in the denominator. My personal preference, so both versions work, I tend to like to put whatever I'm solving for, my unknown, I like to put it in the numerator. It just makes it easier when I go to do my solving. It's not necessary specifically, it's just kind of a nice, easy trick. All right, so let's go ahead and do a few of these. So here we have angle ABC. Just like before, we're going to set up a non-right triangle. And since it's an ABC, we're going to label our triangle. So here's little a, little b, little c. And we have here that, do it in a different color, A is 8, B is 64 degrees, C is 38 degrees, and we want to find the length of sides B and C. All right, so remember what we said, you needed to have a pairing of a side and an opposite angle. So right now I don't have that. But given I was given two angles in a triangle, remember that the sum of the angles in a triangle all equal 180. So my first step is going to be to solve for angle A. So 180 minus the 38 minus 64 leaves me with the measure of angle A, which is going to be 78 degrees. So I can put that in here now. Now I have a pairing of a side and an opposite angle. So I'm going to set up my law of sines. So since I'm looking for a side, I'm going to use the second version where the sine is on the bottom. So my ratio is that 8 is to the sine of 78 as, so if I'm going to solve for B, that goes on top, is to the sine of 64. And since I'm solving for B, what I'm going to do is multiply both sides by sine 64. And that will isolate B. Now, I will do this all at one time on my calculator. My one cautionary note to you is if you have a calculator that automatically puts parentheses before the 64, before your angle measure, make sure you close that parenthesis before you hit divided by. So I'm going to go on my calculator, and again, you might want to pause this video and try it on your own and see if you get the same thing I get. So I'm going to go 8 sine 64, close my parenthesis, divided by sine 78. The parenthesis at the very end of your equation doesn't matter, but you can close it if you want. You should get B is 7.35. Always give us at least 2 decimal places, please, for accuracy. Now, when I go to find C, I'm going to use the same scale factor here. 8 is to sine 78, as now I'm trying to find little c is to the sine of 38. And again, I can now just multiply both sides by sine 38. This is why I like to have that unknown on top, because I can then just cross cancel that one, that one value. So we end up with C, and again, if you want to pause, try this on your own. So you would go 8 times sine 38, close your parenthesis, divided by sine 78. You should be able to enter it all in one time, and you get 5.04 for the length of that side. All right, so basically law of sines is just solving a proportion. Now, let's do a little bigger problem here. So we have triangle XYZ. So let's draw out our triangle. Here is X, Y, Z. So this is little x, little y, little z. And let's write down what they gave us. So they gave us X is 3, Y is 7, and angle Y is 65. And what do they want? They want us to solve the triangle. So when you're solving a triangle, what I'm going to ask you to do, if you're doing it on paper, I realize sometimes you're just doing things on big ideas, we're going to ask you to make a little table. So it's going to look like this. So we have angle A. Oh, sorry. No, we don't have an angle A. This. See if it'll do it back. Okay, so we have angle X, angle Y, angle Z, little x, little y, little z. Now, some of these I can already fill in. We know little y is 7. What did that just do? It just made it so I can't write. There we go. Little y is 7, little x is 3, big Y is 65. All right. So then we'll do everything else in a different color. So those were our given informations. We need to find everything else. Since I have a pairing here, I'm going to use my law of sines, and I'm going to solve for an unknown angle. Since I'm solving for an unknown angle, I'm going to put the angle on top. So I know that the sine of 65 is to its opposite side, as the sine of this unknown angle is to its opposite side. So that means all I have to do is multiply both sides initially by 3 so that those cancel. And let's get a decimal for that. So 3, we have here 3 sine 65, close parenthesis, divided by 7 is going to give me 0.388. Got out my magnifying glass here. 0.388 equals sine x. So again, we don't want sine of x. We want to know what is the measure of angle x. So to do that, we're going to do our second sine, 0.388. That will then give us angle x. So second sine, if you know how to do your second answer button, which is below your negative key on your calculator, it's kind of nice. It dumps the whole decimal down into your calculator. So maybe if you're not sure about that, when we next Zoom, I can show you a few shortcuts on your calculator. But so long as you can get that entered, you should get that x, again, we're going to round to the nearest angle, is 23 degrees. So going over to our chart, we now know that x is 23 degrees, rounding up. To find angle z, I'm not going to do any trig because we know that all the angles have to add up to 180. So to find, kind of show the work here, to find angle z, I'm going to do 180 minus 23 minus 65. So 180 minus 23 minus 65 gives you 92. Well, it's very close to a right triangle, but not exactly. All right. So now that I know that angle z is 92 degrees, my last task is to solve for the side z. And again, I can use my law of cosines and use the same scale factor we started with. It's always good to use something that was given rather than something you found, just in case you made a mistake. All right. Now, however, I'm looking for an unknown side, so this time I'm going to write it as 7 is to the sine of 65 as little z is to the sine of 92. That's going to be the setup. Again, if you'd like to pause the video so that you can have a chance to kind of work this out and then check your answer, that would be a great way to do this. All right, I'm going to keep going here. So I'm going to multiply both sides by sine 92 so that it cancels out here. And then on your calculator, you're just going 7 sine 92. You don't even need the multiply before the sign, it understands it. Close parenthesis, divided by the sine of 65, and I get 7.72 is the length of z. And now we have solved for all the sides, all the angles in my triangle. Okay? I hope that helped. And again, that's why we have the office hours now. So if anything didn't make sense, feel free to jump in. Or if you just need me to work with you one-on-one, please, I don't mind setting up a personal Zoom time with you. All right?